Okay, so we're pivoting a little bit in this next unit. We're going to be done with linear equations for a while and linear functions, and we're going to move on to exponential functions. And the key word in an exponential function is the word exponent. So we're going to start by introing the properties of exponents and what exponents are. If you're unaware, an exponent is also called a power or a degree, so also known as powers or degrees. And all an exponent tells us is it tells us how many times the base multiplies itself. It tells how many times the base multiplies itself. And I'm sure everyone's seen an exponent. It's that little tiny number that's usually written above another number. Okay, x squared is x to the second power. At this point, I'm sure everyone's seen an exponent. If you haven't, it looks like this. So for example, here we have x to the fifth power. Okay, that 5 is the exponent. Okay, that 5 is the power. The base is the big number, or in this case, the big variable. It's written normally on a normal line. The exponent is raised. Okay, that's why we often say x raised to the fifth power, or x to the fifth power. All right, what does x to the fifth power mean? Well, again, it tells how many times the base multiplies itself. Okay, forgot to write itself. So x to the fifth power means x times itself 5 times. So x times x times x times x times x. X to the fifth power. 3 squared, or 3 to the second power, is 3 times 3. Okay, so it's just how many times we write itself. And instead of writing 5 x's in a row, x to the fifth power is much easier. Okay, so now we're going to look at the properties of exponents. There's 5 main ones. The first one is the product property, or we'll call it the product rule. It's also sometimes called the product of powers. So the product rule, or the product of powers. The product rule states that if you have 2 of the same base being multiplied together, then you just add their exponents. So if you have 2 of the same base, so the same big number or the same big variable, and you're trying to multiply them together, then you want to add their exponents. And every time we do a new rule, we're going to do it symbolically, and then we'll do it with an example. So symbolically, this is saying, what if if a is our base and m is our power, so a to the mth power, and we're trying to multiply it by a to the nth power. Well, then all you would have to do is your base would stay the same, and you would just have 1a. Okay, whenever you're simplifying, you only want to have, your final answer should only have 1 of each base. So we're going to have 1 base of a, and then we would add their exponents together, m plus n. All right, so let's do one with numbers. Say we have x to the fifth power times x to the third power. Okay. Well, according to our property, we would just take the base of x and add their exponents together, 5 plus 3. This will give you a simplified x to the 8th power. Okay. All right, why does this rule work? Well, again, recall what exponents are. X to the fifth power means there's 5 x's over here, all being multiplied together. X to the third power would mean 3 x's all multiplied together. Okay. When we're simplifying, we just want a total. How many total x's are there? Well, there's 5, and then there's 3. It's 8 total. X to the 8th power. So the product rule is pretty easy. You got the same base, you're multiplying the same base together, you add their exponents. All right, the next rule is the quotient rule, or the quotient of powers. It's very similar to the product rule, but this one states that if you're dividing the same base, you want to subtract their exponents. So if you're dividing the same base, you subtract the exponents. All right, so let's look at it symbolically again. So this time we have a to the nth power, and this time we're dividing it by a to the nth power. Well, to simplify this, all you would do is, since they have the same base, a base of a on top, base of b on, or a on the bottom, you would write one base a with their exponents subtracted, so m minus n. Okay, so let's look at one with the numbers in it. So we have x to the 5th power again over x to the 3rd power. Same base, we're dividing, so you just subtract their exponents. X to the 5 minus 3, which is x to the 2nd power, or x squared. Now again, why can we do this? Why does this work? Well, break it down again. X to the 5th power is 5 x's all multiplied together, divided by x to the 3rd power, 3 x's all multiplied together. Okay. Anytime you have a common factor on the top and the bottom, anything something matches top and bottom, they cancel out. So you cross out an x on top, if you cross one out on the bottom, if you cross one out on top, cross it out on the bottom, top, bottom, until you're only left with top, with the x's on top and nothing else on the bottom. Well, how many x's do you have on top? There's 2 left over, x times x, or x to the 2nd power. Let's do another example, this one a little longer. Let's say we have a bigger fraction. Let's say we have 8x to the 4th, y to the 2nd on top. And we're going to divide that by 2, x to the 2nd, y on the bottom. Okay, well, what do we do with the numbers? Well, numbers are still numbers. Okay? If you're trying to divide two numbers, you just divide them. You're not subtracting the numbers. Okay, the numbers are, 8 and 2 are bases. Okay, they're not the same base, so these exponent properties don't work for that. So if you have 8 on top and 2 on the bottom, you just do 8 divided by 2. And then you move on to the x's. You're dividing x to the 4th by x to the 2nd, same base, subtract their exponents. Same thing with the y's. Y to the 2nd on top over y. Okay, remember, if something doesn't have an exponent, it's to the 1st power. Y to the 2nd over y to the 1st. And then just simplify each of those. 8 divided by 2 is 4. Again, the numbers you just divide. Same thing if there are numbers in the multiplication problem. If you would just multiply the numbers together. All right, and then 4 minus 2 is x to the 2nd. And 2 minus 1 is y to the 1st, or just y. Okay, so we got product rule, we got quotient rule. Next up is a power rule. Okay, there's actually 2 power rules, so we'll call this one power rule 1. It's also called power of a power. All right, so what does that sound like? A power of a power. Okay. So in power rule 1, or power of a power, it's when you have an exponent that's being raised to another exponent. A power on top of another power. If you have an exponent raised to another exponent, then the power rule number 1 says you have to multiply those exponents together. All right, so again, let's look at it symbolically. Say we have our base of a raised to the nth power, but then the whole thing is being raised to the nth power. Well, a power raised to a power says you multiply, so you just take that base of a and multiply m times n. Let's look at one with numbers. So we have x to the 5th power again, raised this time to the, say, 3rd power. Let's stick with the 5 and 3. right, so we got x to the fifth raised to the third. Okay, well, according to our power rule, we would just multiply those two exponents together. Be x to the fifth times 3, x to the 5 times 3, which is x to the 15th power. Okay. So why does this one work? Well, instead of thinking of this as a power, we could think of it as a, going back to the definition of an exponent. X to the fifth raised to the third, we could think of x to the fifth as our full base. Okay. So we really have an x to the fifth as our base raised to the third power. So what that means, by the definition of an exponent, it means x to the fifth times x to the fifth times x to the fifth. And what is this? Well, this is the same base being multiplied together. This is just the product rule. And in the product rule, it would state that we have to add all those exponents together. 5 plus 5 plus 5 is x to the 15th power, which is the same thing the power rule told us. So this goes back to the definition of multiplication. Definition of multiplication is just repeated addition. Okay, so the power rule is just based on the product rule. So we called that one power rule 1. So next obviously will be power rule 2. And you guys don't need to know the names of any of these rules. You just have to know how they work. Okay. Power rule 2 is also called the power of a product. So the first one was power of a power raised to another power. This one's power of a product. So this one's a product raised to a power, multiplication raised to a power. All right, so power rule 2, and this is the one a lot of people mess up. In power rule 2, we're distributing, and we're not really distributing. We're not doing the distributive property. You're distributing in the sense, in the the formal definition. You're kind of handing out. You're giving things to the bases. Okay. We're distributing the exponent to each base. So again, this is not the distributive property. It's the definition version of distribute. Okay, so we're passing out an exponent to every single base. Okay. So let's look at our variable version. Let's say we have the multiplication a times b times c, and it's being raised to the nth power. Okay, so you have a product inside the parentheses, a times b times c, three things multiplied together, and then the entire product is being raised to the nth power. Okay. So when we distribute the m, all that means is we're going to raise each one of these bases to the nth power. So we're going to raise a to the nth power, and then b to the nth power, and then c to the nth power. All right, so let's look at our example with numbers in it. Let's say we have 4 times x to the third times y. And then we're going to raise that whole thing to the second power. So 4x to the third y raised to the second power. Okay. A lot of people mess this one up because they don't realize that 4 is a base. There's 3 bases here. There's 3 separate bases being multiplied together. So you have 4 as your base, you have x as a base, and you have y as a base. So when you distribute, you are raising each of the bases to the second power. So 4 to the second power. What you do not want to do is you cannot multiply that. You're not doing 4 times 2. You're doing 4 to the second power. And then raise x to the third to the second power. X to the third to the second power. That's a power of a power. That's the other power rule. That's an exponent raised to another exponent. And then y doesn't have an exponent. It's really y to the first. But we're just going to raise that base to the second power. So now when you simplify this, 4 squared, 4 times 4 is 16. Okay, you always want to simplify your numbers. X to the third squared, power raised to a power, like I said, power raised to a power multiplies. So 3 times 2 is 6. and then y squared is just y squared. Next up is the negative exponent property. Now, as you probably know by now, there's a lot of kind of weird rules in math. There's things that we're not supposed to have. One of the things we're not supposed to have is negative exponents. None of our final answers, none of our simplified answers can have a negative exponent. So what if we do have a negative exponent? What do we do with it? If you have a negative exponent, you just flip it. What does that mean? What do I mean by flip it? If it's on top, you move it to the bottom. If it's in the numerator, you move it to the denominator. If it's in the denominator, you move it to the numerator. Okay? If you have a negative on the bottom, you put it on top. Or if you have a negative on top, you just move it to the bottom of the fraction. All right, so there's two versions you'll see of this. The first one is, what if you just have a raised to the negative m power? If you have a raised to the negative m power, well, there's not a fraction, there's not a top or a bottom, so you have to make a fraction. Really, remember, any number can be written as a fraction over 1. So if you flip it that over 1, so really this is over 1, if you flip that over, you would have 1 over a to the mth. Okay? When you flip it, when you move it from the top to the bottom or vice versa, it becomes positive. The other version of that is, well, what if it was written the other way? What if you have a fraction, but there's a negative exponent in the bottom? Well, if that's the case, you just flip it over, move it to the top, and make it positive. It would just become a to the mth. So 1 over a to the negative m, the same as a to the mth. So let's look at one with numbers in it. We're actually going to look at a couple of these. First one, what if you have x to the negative 5th power? If you have x to the negative 5th power, you can't have a negative exponent, so you turn it into a fraction, move to the denominator, and make it positive. Let's look at another example. What if there's another base in there? What if we have 2 y to the negative 3rd? Now remember, 2 is a base. 2 is a base and y is a base. Okay, we have to treat each base separately. Okay, 2 is a base and 2 has a positive exponent. It's 2 to the 1st power. So what do we do with that 2? We know we have to move the y to the denominator. Well, 2 has a positive exponent. So we don't have to move it anywhere. It can't move. It just stays where it is. It's going to stay on top. And the only thing we're going to move is that y to the negative 3rd. And it's going to become y to the positive 3rd. But again, that 2 has a positive exponent, so you don't want to move it if it's already positive. If you moved it, it would become negative. So careful with the numbers. Okay, remember, numbers are bases too. And let's look at a bigger one. Let's say we have y to the 4th times z to the negative 3rd over x to the negative 2nd w. Well, we have 2 negative exponents here. You got the z to the negative 3rd. Okay, we can't have a negative, so we're going to have to move that to the bottom. You also have x to the negative 2nd on the bottom. Can't have negative exponents. Can't have them anywhere, so we're going to move that one to the top. The 4 stays where it is because it's positive. The w stays where it is because it's positive. It's being raised to the positive 1st power. So when we simplify this, we'll move the x to the top, keep the y up there because it's positive, keep the w on the bottom because it's positive, and move the z to the bottom. And then the last property we need is the zero exponent property. This one's kind of hard to think about, and again, kind of like with the negative exponent rule, this has to be true. Okay, it doesn't, if you think about it, it doesn't really make sense in terms of what an exponent is. But if this isn't true, then math would break. It has to happen. Okay. All right, so the zero exponent property just states that anytime you have something raised to the 0 power, a to the 0 power, anything to the 0 power is always going to be 1. Now, if you try and think about it, how do you multiply a number times itself 0 times? Wouldn't that just be 0? Well, no, it can't be. It has to be 1. Okay? And there's a quick proof to this that I'll show off to the side. So we kind of work this backwards. If we have 1, well, what's another way of writing 1? You could write it as, 1 is the simplified version of a fraction over itself. A number divided by itself is always 1. So what if we had x over x? X over x has to be 1. 5 over 5 has to be 1. Anything divided by itself is 1. We know that. Well, really, we have x to the first power divided by x to the first power. That's the quotient rule. The quotient rule states if we have the same base and we're dividing, we could just subtract their exponents. So their exponents are both 1. 1 minus 1 is 0. So that means x to the 0 power has to be 1. Because all of these things are equal. So this is the easy one. People still miss this though. Let's look at another example. Let's say we have 4 x to the 5th, y to the 3rd, to the 0 power. Well, anything to the 0 power, it doesn't matter that this is this big long base, it's actually 3 bases, each one raised to the 0 power, the answer is going to be 1. Then one last one. What if we have 4 x to the 0 power? This one's not 1. Because remember, numbers are being raised to powers too. The 4, and we don't write it like this, but 4 is being raised to the first power. It's 4 to the first power times x to the 0 power. The 4 is not being raised to the 0 power, only the x is. So only the x equals 1. So then you're just left with 4 to the first power, which is just 4 times 1. All right, so those are the exponent properties. 0 exponent, anything raised to the 0 power is 1. Negative exponents. You're not allowed to have negative exponents. If you do, you move them between the top and the bottom of your fraction. Power rule 2, if you have a product raised to a power, you distribute that power to each base. Power rule 1, a power raised to another power, you multiply. The quotient rule, if you're dividing the same base, you subtract their exponents. And then finally the product rule, if you are multiplying the same base together, you add their exponents. Okay, so again, you do not need to know these properties by name, but you do have to, be able to recognize them and know how to simplify them when you see them.